All right. Hi, everybody. This video is a little bit different. I'm using my whiteboard behind me because I think it's a little bit easier. But this video, we're going to be tackling adding and subtracting one-step equations. Okay, so I have some equations behind me. We're going to solve those. Before we solve it, let's talk about some things. What is our goal when we're solving an equation? We want our variable, our letter, okay, to be by itself. We want at the end, once we've done all of our work at the end, we want it to say x is something, some number, okay? X equals something. That's what we want. But right now there's a lot of stuff going on, so we need to get this letter by itself. Okay, so that is our goal. Solve for the variable, or we say isolate the variable, which means let's get that letter by itself. Okay? All right, so in our notes, we took some notes and we have some steps. Step 1, we are going to circle our variable. So remember, our variable is our symbol, most likely our letter that we don't know the value of, but we can find out. 2, we're going to draw a line from our equal sign down. And why we're doing that is because we've talked about these scales. We want to keep our equation balanced. One side is equal to the other side, or you can think of it as a seesaw. Okay, so for example, if I had 2 markers on this side, I had 2 markers on this side, they're balanced, they're equal, right? But if I took one away from this side, we're not balanced anymore. This one's too light. We're not balanced. So what do? If I took one away from this left side, well, then I need to take one away from this right side so that we are balanced again. Or let's say I added one. If I add a marker to this side, it's not balanced. So how do I balance it again? I have to add the exact same amount to the other side so it's balanced again. Why do I have so many red markers? I do not know. Okay, so important thing about equations is we have 2 sides of the equal sign, and what I do on one side, I need to do the exact same thing on the right side, or it's no longer equal. What I do to this side, I have to do to this side. Okay, it can be adding or subtracting. Okay, all right, the next thing we need to know is we use inverse operations to get our variable by itself. So this video is just on adding and subtracting. Inverse operations, also known as the opposite. Okay, so we know that the opposite of adding is subtracting and the opposite of subtracting is adding. So whatever's going on next to our variable, we have to do the opposite to get rid of it so that we can get our variable by itself. Okay? All right, so let's look at some of these problems. Number 1, well, they're not numbered. So this first one, 16 equals x minus 3. So let's go ahead and circle what we're solving for. We are circling our x because we don't want to lose track of that guy. Okay, so that is what we want to be by itself. I'm going to go ahead and split my equation down the equal sign so I know my 2 sides of my balance, my scale, my seesaw. So what I do on this side, I have to do on this side. Now, we got to figure out what's going on by our variable. We have x minus 3. Okay, minus 3. This is a negative 3. So if I get my variable by itself, I need to get rid of whatever's going on beside it by using inverse operations. So if I have a minus 3, what is the opposite of a minus 3? A positive 3. What's the opposite of subtracting? Addition. So I'm going to add 3 to this side. Well, let's go ahead and make sure that my equation is balanced. If I add 3 right here, I'm going to go ahead and add 3 over here. Okay, so why did I do this? Why did I do the inverse operation? Because if I have a minus 3, added 3, negative 3 plus 3, this is 0. Right? So if this is 0, essentially this whole side is gone. We can pretend like that's not there anymore. And what I have left is that x. So this is 0. Okay, you might want to cross it out. Theoretically, I could just erase this from the board so you don't see it. But what do I have left on this side? If that has no value, well, I just have my x by itself. And remember, that's my goal. I want x, I want at the end, once I've solved it, for it to just say, well, x equals this. Okay, 16 plus 3 is 19. So that is my answer. X equals 19. Okay? Now, a good way to check your work is to plug this in up here for x. If x equals 19, well, let's look. X, 19 minus 3, does that equal 16? It does. It does. So that means our answer is good to go. We're right. Let's look at the second problem. So please pause this video. Try it on your own. See if you can get the right answer. Okay, let's circle our variable. This is what I want to be by itself. I'm going to go ahead and split my equation down the middle. Actually, no, sorry, not down the middle, down the equal sign. And we want x by itself, so we need to get rid of what's next to it. Right now, we have a positive 4 next to our x. So what is the inverse operation of addition? Adding 4, subtracting. Okay, so I'm going to subtract 4. Oops. I don't know what I was going for there. Minus 4. Let's keep it balanced. If I took away 4 from this side of the equal side, I need to take away 4 from over here. So minus 4 minus 4. Okay, 4 minus 4. Well, this is 0. Okay, so it's really kind of looking like x plus 0. Okay, so this goes away. It has no value, so all I have left is an x. If you want to draw, you can also draw an arrow down this way to show that my x just fell down. And x equals 9 minus 4 is 5. X equals 5. Let's check our work through. If I plug in 5 for x, doesn't make sense. Does our equation make sense? Well, 5 plus 4, does it equal 9? It does. Okay, x minus 6 equals negative 5. Let's go ahead and circle what we're trying to isolate. We're trying to get by itself this x. Now, it doesn't have to be an x. It's any variable. It could be an m. It could be a w. Okay, and I'm going to go ahead and draw a line down the equal sign so I know my two sides of this seesaw, the scale. What do I have next to this x? A minus 6. Use inverse operations to get this x by itself. So what's the opposite? What's the inverse of a minus 6? Inverse is addition. So we are going to add 6. Plus 6. Go ahead and do it on this side too. Plus 6. Because if I'm adding more markers to one side, you got to add the same amount to the other side. Negative 6 plus 6. Well, this is 0. Okay, so my x is just going to drop down. It's just my x over here on the left. This has no value anymore. And then negative 5 plus 6. Be very careful of your signs, okay? That's a negative 5 plus 6. Don't think it's 11. Negative 5 plus 6. We're adding more. It's going to be 1. Let's plug in our work here. 1 minus 6. 1 take away 6 was negative 5. That's good. Okay? All right, let's do 3 more problems. And please, please, please be solving this alongside me. I'm glad you're already here watching this video. Like and subscribe, right? I don't know. That's what people say. I'll use a different letter this time. How about Y? Okay, so if you want to go ahead and write these problems down on your piece of paper that you have right next to you, right? You can do that. So again, pause this video. Try these out on your own. You can do it. I believe in you. But if you can't, that's okay. That's why you're watching this video. So you can learn how. Our first problem. Okay, so I'm going to go ahead and circle my variable. That is what I want to be by itself. That's what I'm solving for. I'm going to go ahead and split my equation down the equal sign. I want this y by itself. So what's going on next to this y? We have a plus 5. So how do I get rid of a positive 5? Well, I got to take it away. Got to take away 5. Minus 5. Make sure you do it on both sides, though, because like our seesaw, we want it to stay balanced for our scale. So this equals 0, so we don't have to worry about this guy anymore because it has no value. We just have our y. So our y drops down. 13 minus 5 is 8. So our y equals 8. And we can plug this in to see if it makes sense. 8 plus 5, Does that equal 13? It does. I guess I should show you this, right? There you go. All right, our next problem, y plus 9 equals 2. We are trying to solve for our y. Go ahead and split this down, the equal sign, so I know my two sides. What I do on this side, I need to do on this side. I have a plus 9. How do I get rid of a positive 9? Right, the inverse of adding is subtracting, so I'm going to take away 9 from both sides. This equals 0. So I don't have to worry about that anymore. There's no value there. I still do have my y. And then 2 minus 9. Be careful here. Okay, think about this. What makes sense? 2, take away 9. You're taking away a lot. That's going to be negative. You're taking away more than you have. Negative 7. Okay, last one. 10 equals y minus 12. I'm solving for this y. Go ahead and split this equation down, the equal sign. So again, what I do on this side, I have to do on the other side. What's next to our y? We want y by itself. Right now I see a minus 12. So what's the inverse operation of minus 12? Inverse of subtracting is adding. So I'm going to add 12 to both sides. A lot of you guys want to put 24 right here, but be careful. This is a negative 12 plus 12. If you have a 24 on that side, that means you might have done something wrong. You probably did do something wrong because we would end up with y plus 24, but we want our y just to be by itself. So whatever you do right here needs to cancel out, needs to go away, have no value because we want just y by itself. So that's has no value, so our y comes down here. And then 10 plus 12 is 22. Y equals 22. Again, plug that back in, see if it makes sense. Y equals 22. 22 minus 12. Does that equal 10? It does. Okay, so let's recap here. We are using inverse operations to solve these one-step equations using addition and subtracting. Whatever is going on next to the variable, the letter, you gotta do the opposite. You have to use the inverse operation because we want this to equal 0 at the end so that our letter, our variable, can be by itself. Okay. What else? What else? Remember what you do on one side of the equal sign, you have to do to the other side. And always, always check your work. It's so easy to check your work. Whatever your answer is, plug it back into your equation. If it doesn't work, that means you should try again. Okay, so this is my video on adding and subtracting, solving one-step equations using addition and subtracting. You can rewind this, watch it again, solve my 6 problems all over again with me. Be very, very careful of your signs, okay? If you have a negative number and you're taking away more, it's still going to be negative, okay? See if it makes sense. See if it makes sense. Hope this helps. See you later.